Hi, in this video, I will show you how to set up dynamic parallel processing with AWS Step function. As you see in this picture, this is just a pictorial overview of an example of how to set up a dynamic parallel processing at AWS Step function. Okay, so here this is my example state machine definition at AWS Step function, which will perform the parallel processing. Okay, so before I walk you through this complete demo, so here the main focus will be on how to write a logic of or how to write a definition of AWS Step function, which will help you to perform a dynamic parallel processing. Yeah. So again, before I walk you through this complete setup, and I will show you a dummy example, like how does it processes the dynamic parallel processing. Okay, so before I show you that, I kind of request please do subscribe my channel. That would really encourage me a lot. Yeah. So with that note, let's directly jump here. Yeah. All right. So I was here. I will show you here two things. Okay. One is how do you write a logic or how do you write a JSON function which can help you to build a parallel processing, a dynamic parallel processing step function. Something looks something like this. Yeah. This is just an example. Maybe if you understand how do you set up dynamic parallel processing step function, probably this will this is the worth of watching my videos. Yeah. That is the my aim under the hood. Yeah. All right. So now what I do is I will show you two steps here. So one is first one, I will walk you through the code. Then I will show you the how to set up at real time at AWS console. And then I will show you an example. Okay. So I will show you like a dummy demo as well. Yeah. All right. So for this purpose, I have created two JSON files and one Python file. Yeah. So one is the stuff function.json file and another one is the stuff input function, because when you want to process the dynamic parallel, maybe you need to have the batch inputs. Yeah. And that is what a step function input file is, an example file. Anyways, these files will be shared in my GitHub repo, and the GitHub repo link will be shared in this video's description. Please find there from there, and maybe you can try to replicate the same demo at your level as well. Yeah. Okay, so as you see in this picture, so this one here, yeah, so here what we do is here you see the step function.json file. Okay, so this is the JSON function body. Maybe you can ready-madely use it, where you just need to replace with the resources AR in here. Okay, so first of all, let's see what actually I'm doing. So okay, this is the scenario based dynamic parallel processing step function. Okay, so maybe in your case, okay, so here in this demo we are focusing on just like catering uh, catering a order, for example. Okay, somebody is requesting the request, then you need to process that orders. Okay, so in that case, that processing of the multiple orders in a batch wise. Okay, so this is the one scenario, and I have articulated that scenario in the form of dynamic parallel processing. Okay, so here what you learn is, maybe you can just learn the body, learn the syntax, right, and learn the learn the how does this being joined together, and to enable the dynamic parallel processing. Yeah. All right. So that is the majorly all my videos is to just to enable you to consume the service. Okay, may not be this is a ready-made production consumable solutions, but yes, these are kind of a POCs or kind of a lab through which you understand the process, and maybe you can you need to think it better while you are applying at the production level. So here let's see, okay, how I am articulating or how I am writing or how I'm designing this. Okay, this parallel processing, dynamic parallel processing step function definitions. Okay, so here it contains a big JSON file basically, and it contains state. You see the everything. Okay, so as you might be aware, every step function starts with a definition called starts at, and after that we have state as well. Yeah, state is nothing but as the step function is nothing but a state machine. Okay, that is where we define everything. Okay, that is where the core definition of a step function will be defined here. Yeah. All right, then one at the state. Okay, so if you see start at, in the sense every step function definition starts with a keyword called start at, nothing but it will indicate the step function that you have to start the run from there. Okay, so that's the reason it will start from the validate payment from here in my case. Okay, so in this case the validate payment. Okay, so in the validate payment, here the task is equal to, here the type equal to task, in the sense in AWS step functions. Okay, definitions, there are certain keywords are meant for doing the certain tasks. Okay, for example, when I said keywords, in the sense like type, resource, next, yeah, then you have the state, start at. Okay, that is a syntax of defining the step function. Okay, so here inside this state, that is validate payment. So here we have to declare a type. Okay, so every task that you want to perform in step function has to have a type. Yeah, then we are defining a task is nothing but it can be done by any kind of resources in the AWS. Generally generally AWS in AWS step function, we majorly consume step functions only. Okay, because as you know, AWS step function is nothing but a orchestrator. Okay, it's a serverless orchestrator. Yeah, orchestrator solutions, you can say. So here type is resource, which is nothing but just a lambda. Okay, probably validate payment. Let's say in my scenario, I need to validate the payments. Yeah, so in that case, I will write a logic of a lambda where I can perform the the payments. Okay. Okay, then yes, since this is a dummy and just a demo, I have created only single lambda, and I am consuming that lambda across the process, across this step function, and I have adjusted the logic of my step function, my lambda, in a such a way that it will just show you the demo. Yeah. Okay, then the next step is a payment. Okay, so in the payment, you see we are still, again, one more point, we are still within a state. So in this one, next step. Okay, so what does the next tells? Next tells in the sense, once this task is completed, what is the next task I need to process? Okay, because orchestration is nothing but you are doing multiple tasks one after the other. Okay, and that is what orchestration is. Yeah, and the step function, AWS step function, orchestrates your task for you. And here the check payment. Okay, so in the check payment, it is nothing but again a task, but you see the type is changing here. Here is the choice is nothing but you are making either we need to run this task or the another task. Okay, that is where a choice type comes in. Okay, so in the choice we have the choices lab, something like this. Okay, so here what I'm doing is I'm checking the output of the above function, above lambda, and checking if the variable, okay, if the above lambda has a variable called payment, and then payment equal to okay. So this is just I'm trying to think it in a logical wise. Okay, for example, first you are validating whether the client or the consumer has paid the order. Okay, so in that case, if it is paid, then only we need to process something like that. I thought a kind of a business logic. If the payment is okay, then only I consider it as a successful process. It's a successful a kind of work item to process. Okay, that is the reason I have added it here, something like this. Then the next state is payment. You see the for example, here if you see, you might be confused here. Okay, so here is the next step is payment failed. Why? Because I have added the not condition here. Okay, so the next step is payment failed. Okay, so if it is failed, for example, in the sense if somebody has not paid it, yeah, then maybe we might need to directly jump back. Okay, so if I show you the diagram here, we are here start, then this is the task called validate parameter, validate payment. So once the validate payment is true, then only it will process the order, or else it will just go to the failed order. Yeah, that is where the logic is coming in. Yeah, all right, so that is a big step function. Maybe in your case it might vary, yeah, less than this one or greater than this one, yeah, or maybe equal to this one as well. So the check payment is here. Here is a choice. Then in the choices, I'm just validating the not condition, in the sense whenever it is true, it will go to the fail. Okay, whenever it is for example, not in the sense whenever the payment is not equal to okay, then only it will go to the failed state, or else by default it will go to the processing state. Okay, that is where. So again, for failed orders as well, we are running a one more task called a lambda only. In the sense the failed orders will be processed again by another lambda. Yeah, so that is how the orchestration is going on. And the next state is which is the thing I like to show you in this video. This is very important part of this definition, okay, of this demo. Yeah, okay, so what is the specialization of this definition is, yeah. So you might have earlier watched a kind of a scenario where you would like to process the request in a parallel manner. In the sense, let's say you have statically defined the task in a parallel wise. For example, like task X, task Y, task Z. Okay, maybe those tasks will be processed in parallel stretch, and which are constant one. Okay, irrespective of it is failed or passed, those tasks will be processed parallelly. Those are called as a parallel task. But if you want to process it dynamically, in the sense based on the request type, if you want to process it, then that is where the use case of type called map. Okay, so whenever you want to process dynamically, yeah, dynamically parallel processing, then in that case, we will be using a type called map. Okay, so in this one, so this is the syntax of the map. Okay, so if whatever I'm selecting here from the line number 27 to line number 64, these are the definition of the map, nothing but parallel processing. So here the type is equal to map, the input details. Okay, input details is nothing but when you are processing the map or dynamic parallel processing, yeah, then we will be consuming the two parameters. One is the input path and the input input path and the items path. Yeah, so input path and what is items path? Okay, let me define and let me explain you. So if I go back to the input here, okay, so this is the input which I will put while executing my step function. Okay, so let me tell you what is the what does this means. Okay, for example, input path, in the sense the path that the complete, you can think it like a complete dictionary to which it has to be put in, to which it has to be act as to which a complete dictionary which will act as a kind of a input to the parallel processing. Okay, so here this is the so here the items. Okay, so if you see the items is nothing but it's kind of an input here. So yeah, so here input path is items, but the input items path is this one, but input path is something else. Okay, so in the in the details, if you go to the details, okay, so here, right, so this will becomes as a input path, yeah, and items becomes it as a items, right. So you see the items path. Okay, so the item, what is the items, what is the difference between the input path and the items path is nothing but input path becomes kind of a a complete dictionary that we will feed into the into the map. Yeah, and in that input path we want to consume some specified dictionary again, or some specified items. Okay, always remember that. So input path is always dictionary, but items path is always a kind of a array. Okay, that is one important thing we need to understood. Then here one is a very important point, that is one more very important property, that is maximum concurrency. Yeah, so maximum concurrency by default, it supports like maybe n number of maximum concurrency, but there is a limit. Maybe you can check it at the AWS document in that case. But by default, if you set it as equal to 0, then it will become unlimited processing. Yeah, but if you set it 3, nothing but it will try to process the your work items, or work items in a batch wise of 3 in a one stretch. Okay, after processing the 3, it will pick up the another 3 from the items. Okay, for example, in the items list, okay, so here if you go here, right, so it contains, so let me, one, this is one item, this is 2, 3, 4, 5. Okay, so these are the orders. Okay, nothing, items is nothing but orders. Okay, because this my solution is processing the orders. Yeah, so this is 1, 2, 3, yeah, and 4, 5. Yeah, there are 5 orders. Okay, 1, 2, 3, 4, 5. Yeah, so there are 5 orders, but I have declared here, right, I am declaring the batch maximum concurrency equal to 5, right, maximum concurrency equal to 3. In the sense, how does it process? First batch will be processed equal to 3, and the next batch it will process only 2 numbers. Yeah, so that is how you need to understand, like what does this parallel process all items means. Yeah, all right. And the next one is iterator. So iterator is nothing but this is the place where where actual this is the kind of a mini state machine within the step function where your work items will be processed. Okay, and that is okay. It's not always recommended. It's not always that you need to do only one task. Okay, maybe like in my case, you might need to process multiple tasks as well. Yeah, so since this is this is a ordering, this is the ordering kind of a state machine, so it will check two things. Probably this is just a business logic. Okay, check if the order is available, order item are available, or order object is available. Then check then prepare, if it is available, then prepare it for the delivery purpose. Then the start delivery purpose. Okay, these are the tasks that you like to iterate per each work items, or each items that you need to iterate. Okay, work items in the sense for example, if you are a developer guy, you might know that a array will have the items. Okay, so you and when you are doing a for loop, yeah, maybe if you are a coder, you understand what is a for each or for loops, where we will iterate the items present in a list one after the other. Okay, that is what it does. Okay, but here it will do in a batch wise manner. Okay, all right, so it will run first 3 orders will be processed for these 3 tasks one after the other. not one after the other. All the three first orders will be running for these three tasks in a parallel manner. Okay, that is where the dynamic parallelism is all about. Yeah. So here what I'm doing. So again, right, the iterator, inside the iterator, we are again running a state machine. Okay, so if I show you here, so you see that is what I was telling, right? This is a mini state. Okay. So under this state we are running again tasks. What are the tasks you need to process for that work item, or the items within a list? Here again I'm running a lambdas. This is just a dummy, this is just dummy. Okay, that's the reason you may not be correlate the logic, but this is how we need to define a dynamic parallelism. Okay, so here task is again type is equal to task, then I'm running a lambda. In my case, I have made some small logic in the lambda. I will show you, so that that lambda caters all these tasks. Okay, but at the business logic, maybe you need to change the logics. Okay, now we are the check availability. Okay, in this case, this lambda will run and check it will process the check availability, and then once it is available, then it is then it will pass that input to the next task. Okay, if you see the next task, right, we are defining prepare for delivery. Again, that is again a one more lambda, and it will process and it will give the output to the start delivery task. All right, so if I go here, the start delivery task, so this is the task, and here you go, right? All right, so once that is done, the next task, okay, if you see the difference here, there is no next task here, but directly that's the end, because once you start the delivery, that's all, you have processed your order. Yeah, that is what it means. Okay, and finally the results. Okay, the result path is again it will be processed here. Okay, I will show you what does that mean. Also, we will see it at real time. Okay, so the result paths. Okay, so you need to understand one more important thing here. Okay, at the process in the map. Okay, in the type task type equal to map. Yeah, so it also contains a property called result path. In the result path, we are storing some processed items, and then lastly we are calling the sending a summary. Okay, this is just a dummy, as I said, this is just a dummy step function. This is how you need to articulate your your own dynamic parallelism at step function. Yeah, and finally, okay, so finally we are running a last task. Okay, that is called send summary task, and let me show you here as well. That is, so here you go, right? Send summary task. Okay, that is where how it processes. Okay, so and here you go. The send summary task is nothing but again it's just a lambda which will run it. Yeah, and here the input path, if you see, it's just a processed items. Okay, and finally at the result path you see the detailed summary as well. Okay, so I have walked you through this complete code, and this code will be put in my repo as well. Maybe you can use the same syntax and try to change here and there and make your task designed with using this help. Okay, and that is where my videos are dedicated for you. All right, now as I explained earlier, right? So this is our step function input JSON function, step functions input. Okay. So right now I will be inputting this JSON input manually. Maybe at the real-time application or at the production, you might be, this step function might be invoked by another lambda, which will read the queue messages from the queue and invokes this step function as a batch input. Okay, and that is also just a logic I'm explaining. Yeah. All right. And now finally the lambda. Okay, so what is the magic I did? Okay, so here to show you all these tasks. Okay, here we are defining the type task. Okay, task type equal to task nothing but lambda, and I have written like 5 lambdas. Okay, not only 5 but this is 6. Okay, let me copy and paste. This is also a lambda. Yeah. All right, so as you see here, so this is my step function, and we just saw it. Okay, so here we are just starting, then we are validating the payment. Once the payment is validated, then it will go to the dynamic parallelism definition. Under the dynamic parallelism definition, I am running three tasks per one iteration. Yeah, so here check availability, prepare for the delivery, start delivery, and finally sending the summary. Yeah, so that is how we saw the definition. All right, and in the lambda it's just a simple dummy lambda. Okay, so it's a lambda handler. I'm just printing the event, and what I'm doing is I'm just making small change, like when it is a payment. Okay, at the first time when you have the payment, and in the payment, yeah, in the payment, if the value equal to check, I'm just changing it. Okay, if I'm just changing it to okay. Why I'm changing this okay? Why? Because if you see down, okay, if you see my step function definition, right, so it will only invoke our all process all items are nothing but our map or dynamic parallelism. If the variable payment equal to okay, right now I'm just putting it payment equal to check just to showcase you, okay, so that so that you are aware that Lambda is doing something, yeah. So that is what I mean, okay. And finally, we are returning the input. And next, when it iterates, okay, when it goes through the um, map or a dynamic parallelism, maybe it will not come here, it will not come this loop, but it will just print this and keeps on returning the event, okay. Yeah. All right, so this is just a dummy, very simple Lambda. Now let's see at the real time, because till now I have just walked you through the code. Maybe it was very boring. Let's go to the very interesting state. Here what I do is I will show you that I first create a Lambda for this case, okay, for this demo. So what I do is I just create a Lambda called, now what is my Lambda, what was my Lambda? So I have defined here, so you should keep this Lambda name same, okay, for your information. So I go here, I put this Lambda name and I choose the runtime equal to Python 3.8, and I go to the execution role and I use the existing role. Okay, maybe in your case you might need to configure this Lambda with using infrastructure as a code, but this is very simple, right? Just if you, let's say if you have only account and you are setting this only infrastructure, maybe you don't need to scratch that much head to manage it as infrastructure as a code. Just keep it with using Lambda or with using with using Portal only. That is what I suggest you. All right, maybe at the enterprise level, yes, definitely we need to keep it as infrastructure as a code. All right, so now what I do is I just create this Lambda, and then we will copy paste this code, okay. So let me copy this code and let me copy this code, yeah. And here you go, my Lambda is ready, yeah. It's the AWS is very super fast in this case, okay. So what I do is in this Lambda, so by default AWS creates a Lambda with a Lambda file, okay, with a Lambda file with minimum code, okay. So this is my code, but in this case I will just replace this code with my code which I have explained you. So let me put this and I will click on deploy again, yeah. Nothing but I'm just changing the logic so that it will help me to show you a demo at AWS Step function, which is nothing but dynamic parallelism Step function, yeah. In the general configurations, by default it will complete in 3 seconds. Maybe I will change it into something like 60 seconds, okay. Let's keep it very simple, 60 seconds, yeah, 1 minute. And memory this much is enough for me because this is just a small demo, yeah. All right, so this is I have set the Lambda. Now let's go for the the boss, okay, the step function here, which is the orchestrating solution, which is orchestrating our work items in a dynamic parallel, okay. And really that will, what is the advantage of dynamic parallelism? While I creating this state machine, let me explain you. So dynamic parallelism, it saves your time, okay, because let's say you can process it one after the other with using for loop, but in that case you are burning the Lambda, but also, and you're also wasting that much time, okay. Because for example, let's say you are iterating 100 work items, for example, yeah, and each work items consumes, let's say, 1 minute, then you will be burning maybe 100 minutes, okay, which is nothing but 1.3 hours, maybe greater than that, yeah. But in that case, if you are using the dynamic parallelism, then you are saving that much time, okay. You can process those many work items within 1 minute as well, even, yeah. And you will be saying 1 hour, okay. So that 1 hour gives a value to your business, okay. All right, now let's create our own state machine, okay. So for this case I'm just write your workflow in the code, okay. That is what the option I'm choosing. Then okay, here we go, I just need to copy paste the code which I have written here in the JSON format, okay. I will just copy this and I'll replace all this. All right, okay. And right, if I put that code, automatically it is changing. If I do Control Z, see, it is going back, okay. That is how that is cool, that is how this cool this infrastructure is, okay. This is how okay, this complete is cool, okay. If you see here, you are seeing 3 dots, okay. If I can maximize, if I'm not sure, yes, here you go, 1 2 and 3, okay. You are seeing 3. Why? Because I'm defining here, okay. If I change the let me show you the magic here, okay. Maybe this would be looks very interesting to you, right? If I change it to 0, let's see how does it looks, yeah. If you change it to 0, in the sense you are making unlimited, okay. Note for your information, huh? If you are giving some if you are giving some concrete integers, then in the sense you are making that you want that much batch processing limit, okay. If you are setting 0, then nothing but you are giving what is the capacity of this step function, doing the dynamic parallelism, that much you are telling to do that. Yeah, maybe that is not a right case. Yes, I would suggest you to give a concrete integer. Okay, let's say in this case, since I have the 5 work items, let me process it in a 5 case. Okay, and if I can show you that now right now it will have the 5 one. Yeah, yes, under the hood it will just show you the by just it will show you these dotted. I was wrong. Okay, so it will just show you as a saying like it's a kind of a parallel processing symbols, but in real time it will process in a batch wise of 5. Yeah, okay, all right, I changed it to 5 and let me go to the next. Yeah, and I will tell him, okay, I'm telling to create your own boss, you create your own step function. Okay, and let me give a step function as something like order. Yeah, let's me give the my state machine name as a order, and in the permissions, okay, I'm telling yes, AWS step function, create your new role. Okay, all right, that is in the permissions, and the rest all configurations I keep it by default. Let me go to the create state machine. Okay, and just clicked on the create state machine. It takes it takes very minimum time. Okay, you see, if you see the machine is created successfully. Yeah, all right, and here you go, we are ready now, we are ready to consume the state machine or step function. Yeah, here you go, my step function called order is ready. Now it is time to time to show you a demo real time. Okay, so how do I show you a demo that it works in a parallel? What I do is I go here, I copy this input. Yeah, I copy this input as I said and as I explained. So this is how my input should look like. Yeah, and I will execute my step function. So I will go to the start and I will just replace the input value from the by default to this one. Yeah, all right, so if I can scroll up, so here you go, my input is something like this, and I will tell start execution. If you see it within fraction of second, it will the processing gets completed. Okay, that is how fast it is. Okay, if here you go, right, your step function is it just run in a eye opener. Okay, for your information, it has not run for only one time, but but it has run for 5 times. Okay, it has processed 5 work items. Okay, so that lightning speed you can achieve with using dynamic parallelism. Yeah, there are many n number of cases where this logic can be leveraged, and you can bring down your business operations at a drastic time. Okay, you can reduce the automation with using this automation. Okay, if I go to the cloud watch, okay, I will show you those those processing logs as well. Since I have a single lambda, you will see logs as well. If I go to the logs, all right, so okay, so what did we see now? We have seen that yeah, so where so what we did is we have created the a step function, and we ran it. Yeah, we ran it, and also we saw this it has successfully processed in a batch manner. Okay, all right, so we saw the one good case. Now let me see the bad case as well. Okay, how does it respond in the bad case? Yeah, so while that loads, let me go to my stuff, my Lambda code, and what I do is I will change it. I will make small changes. Okay, I will make small changes here. Instead of okay, what I do is I will tell okay one, which may not be which it will consider as a fail. Yeah, and let's see in the fail case how does my step function behaves. Yeah, that is the next second demo case I would like to show you. So one order we checked it, and now let's go to the order. Let's order one more thing, okay, which is a failed state. For example, the consumer has not paid. So this is what the scenario. For example, a consumer is not paying the money, but he is ordering, okay, which is not right case. So in this case, how does our automation behaves? Okay, how does our dynamic parallelism behaves? Okay, that is the aim of this one. It should fail. Yeah. All right. Exactly. You see, when I change the value here, okay, when I change the value from check equal to okay one, nothing but in the logic, okay, if I go to the step function, in the logic, we are telling when the payment is done, then only you process the all work items. Else, just go and fail it. And that is what exactly it did, okay? That is what exactly it did, okay? So when it go to the check, if you see the input, yeah, okay, so definition is okay, right? It is expecting payment value equal to okay, but in the input, in the input it is taking I'm okay one, which is nothing but wrong case, and that's the reason it failed. Yeah. All right. Now finally, let's go to the CloudWatch logs. Okay, this is the latest CloudWatch logs. Yeah, and we see the parallel processing. You see, each work items has been processed. You see the order processing complete, order processing complete. You see whatever you see, those are like parallel processing. Okay, So under the hood, what it is doing is, it is creating that many instances of this Lambda and it is processing the request. As simple as that. Yeah. All right. So that's all pretty much for now. I have successfully shown you the things to be shown in this video. Finally, a kind request, please do subscribe my channel. That would really encourage me a lot. Yeah. So with that note, thank you. Thanks a lot and see you in the next video. Thank you.